Hello everyone. So today's class is kind of half time class because we have the exam and then some class time. I know that I'm giving you 2 hours for the exam, so I'm just gonna cover something. Takes much less than the half of the class time, but it's gonna be important for next week. And this is not much physics, so it's more math that we need to understand torque better, and some other stuff later on as well in the maybe next semesters. So we are gonna talk about vector cross product and how to deal with it, what it is, and all the features about it. And I'm not going to do a review today. I know that you're taking the exam, you're more focused on chapter 8 and 9 than chapter 10 for now. And for Monday class, I'm going to do a review of the entire chapter 10 again, okay? So today, again, we are talking about vector cross product, and we are on page 337. So before we can complete our development of torque, we will consider one last vector operation, and it's called the cross product. We did discuss dot product before, and that was again the multiplication between two vectors, and we found out work done using f dot d. F and d were the vectors. F is the force, d is the displacement, right? So that was one of the way of multiplying vectors. Now this is vector multiplication, and it's called cross product. Dot product was also called scalar product because it yields a scalar, which example was the work. And now when you do a cross product between two vectors, first thing you really need to understand is you're going to get a vector as a result, not a scalar. So it will have a direction and a magnitude, okay? So when you write it, you use a cross like that. So these are if you multiply 2 and 3, the scalars, you don't need to show the cross between them, right? You can just use a dot or something. But when you show the multiplication between vectors, it is important to show a dot b. So this was the dot product, or a cross b. Okay, the reason is they are not the same thing. So there are two different ways of multiplications, and they don't give you the same answer. So make sure to use, these are details, but these are very important details, the notation. So make sure to use that x, cross, for this product, okay, a cross b. So the result is a vector, and the magnitude of that vector, the resultant vector, is AB sine theta. Okay, so if you remember, A dot B gave us AB cosine theta in magnitude, and A cross B is giving us AB sine theta in magnitude. So cosine function will be related to the dot product, and sine function will be related to the cross product. And here, since this is a magnitude, A is the magnitude of vector A, B is the magnitude of vector B, and the angle, as usual, is the angle between the two vectors A and B. Okay, the direction of the resulting vector is perpendicular to both A and B, so this is so important. We will have some clicker questions later on. And the right-hand rule is used to determine the direction. Again, we use RHR for right-hand rule, okay? And to use the right-hand rule, I've been talking about this briefly before, so we need to really understand what it is now. Point the fingers of your right hand along the first vector A. The order matters in cross product, so the first vector is your forefingers. Point them along that vector, and then curl your fingers toward this second vector. Okay, so we're gonna see how to do that. And once you do that, the thumb stretched out from the forefingers, perpendicular to the forefingers, is gonna show you the direction of the resultant vector of this cross product. So let's look at the picture here. and try to understand what is going on. So what you're doing here is you are pointing your four fingers. I'm gonna try to draw four fingers here. Let's do this. 1, 2, 3, 4. And your stretched out thumb like this. Okay, so you point your fingers along the first vector A in the cross product, and then curl them towards B. When you do that, your thumb is pointing the direction of A cross B. Okay, and this is then the direction right here. That is A cross B, because that's the direction of your thumb, and that's the resultant of A cross B. The magnitude of this is AB sine theta or phi, the angle between them. And if it was B cross A, what would you do? You wouldn't put your hand like this, right? I'm gonna get rid of this hand. Now you would put your hand towards B, and but it has to be right hand. And you need to stretch out your, again, thumb from the four fingers, and to be able to do that and then curl it toward A, you need to kind of change the position of your hand. So it has to look like this time, and your thumb is pointing down, right? And again, this is along B direction, and thumb is going down, and this will be B cross A. Because then you're gonna put your four fingers, curl them towards A, and your thumb is down, and that is the direction of the resultant between B of the cross product of B cross A. So what you see here is A cross B is upward, B cross A is downward. They are not the same vector. So when you write them as an equation, you have to put a negative sign because they're opposite to each other. Okay, so it doesn't matter where you put the negative sign, but A cross B and B cross A are not the same thing. That's why the order is important, and we call that order cyclic order. I'm going to discuss that in this Cartesian coordinate system here. Okay, so make this a little thinner. Okay, so what we have here is, let's think about this in unit vector notations. Okay, you have x, y, and z, and along the x we have I hat, along the y we have j hat, and along z direction we have k hat. And I, j, and k are pointing the positive directions, as you can see. Okay, and we're going to do I cross j. So these are unit vectors, and you can do cross product between any type of vectors, including unit vectors. And just to remind you, why do we call them unit vectors? Because their magnitude, so if I do I hat in absolute value, what is the magnitude? It is simply 1, right? And the same thing for j hat and k hat, the magnitudes are simply 1, okay? So since we know that A cross B is equal to AB sine theta, and we are going to think about that and using this definition. So the magnitude of this is AB sine of the angle between these two. And let's look at the unit vector notation, unit vectors. So what is A cross J? Okay, so I cross J. So I'm looking at the first one here. So to be able to do that, I need to understand the direction. So the first vector in I cross J is I. So I'm going to put my four fingers along I, and I'm going to make sure that I will be able to curl my fingers towards J. Okay, so I have to really put my hand perpendicular to the XY plane. Okay, and my four fingers are pointing towards I hat, and my thumb is pointing along Z direction. Z is kind of coming out of the page, but with a perspective, this is how we show it on the right side in the Cartesian coordinate system. But what you're doing is you're putting your four fingers along I and then curling them towards J hat. And what is the direction of your thumb? So if I draw my hand in perspective, just so that this is clear, This 3-dimension stuff is a little hard to grasp. Okay, I have a really big thumb here. So you are putting your forefingers along X, along I hat direction, and curling them towards J hat. Your thumb is stretched out and it's pointing along the positive Z direction. That would be positive K. That is the reason this cross product is equal to K hat. Okay, and you will kind of keep doing that to find the others as well. Let's look at J cross I hat. Since you can see that it's like A cross B versus B cross A, right? You just switch those, it will result in a negative sign. Because now what you're doing is you are putting your forefingers along J hat, and curling your forefingers towards X direction. So if you draw this, this is your right hand again. Make sure you draw this for the right hand. So you have like forefingers along J hat and thumb is pointing kind of opposite. So this is negative Z direction, opposite to that. And then curl your fingers towards the X direction. Then you get your thumb pointing along the negative Z direction. And what is negative Z? It's negative K hat. Okay, so that's the direction of the resultant vector from the cross product. I'm going to talk more about it in the next video.